Hey everyone, let's take a look at the quiz review worksheet 10. Remember, this is our quiz review for volume. So we're going to look at the odds. We're going to start with number 3. So this is a triangular prism. The base is a triangle. So the first thing I'm going to do is focus in on that triangle to find the area of that triangle. So sorry about that. If I focus in on this triangle, I see that the base is 8 and the height of the triangle is 4, and that's all I need to find the area of the triangle. The base is 8, the height is 4, so we get that the area is 16. So we're going to use that in our volume formula, which is the area of the base times the height of the prism. The area of the base, capital B, is 16, and the height of the prism is the distance between these two triangles. So H is actually 18. Be really careful. The height of your base is different than the height of your prism. So there's two H's in here. Make sure you know the right one. So the volume formula wants the height of the prism, the distance between those two bases. So we do 16 times 18, we get that the volume of this prism is 288 cubic inches. Watch your units, make sure it's to the third power. All right, number 5, we have a cylinder. So the volume is still area of the base times the height. Our base this time is a circle. So the area of the base is pi r squared with a radius of 4. So we get 16 pi for the area of our base. And then the height of the cylinder is 15. So we're going to multiply through and get 240 pi cubic centimeters. We're done with that one. All right, let's take a look at number 7. Another prism. This time it is a right triangular prism. So the base is a right triangle. So to find the capital B, it'll be 1/2 base times height. But remember, the base and the height in our right triangle are the legs of the right triangle, so we have to find those dimensions. The 26 is the hypotenuse. And then do you see at the bottom base, one of the legs is 24. So we have to find the other leg. This is a Pythagorean triple. This is a 5, 12, 13 right triangle. So this is a 5, 12, 13 triple being multiplied by 2 to get us 10, 24, and 26. So we use that to figure out that our base and our height of our triangle are 10 and 24. So we can get that the area of our base, capital B, is 120. And then we're going to use that in our volume formula. The volume of a prism is the area of the base, which we just calculated as 120, times the height of the prism. The height is the distance between those two, so the height is 10. So we're going to get that the volume is 1200 cubic centimeters. So it's super important to show this work for how you're calculating the area of the base. Don't forget to show that. All right, moving right along. Number 9, I'm still working with volume, but instead of giving us a diagram, they're giving us some descriptions of the solid. So here's a pyramid. So for a pyramid, it's 1/3 area of the base times the height. And it tells us that the area of the base area is 84. So this is capital B. They're telling us right off the bat that capital B is 84. So we can plug that in. Then it says the pyramid has a height of 16. So I can plug that in. And they want us to solve for the volume. So we just multiply across and we get 448 cubic centimeters. All right. Next, we move on to our next section of work, and these look like we have some pyramids and cones, so we're going to have to adjust accordingly. I want to jump down to 13 because we have a composite figure. So with volume, you are either, when you have more than one solid, you're either adding the volumes together or subtracting them. Well, since we're stacking these solids on top of each other, we're going to add them together. So we're going to take the volume of the pyramid and add it to the volume of the prism. So here's my plan. I'm going to write down my formulas underneath. And just like before, I need to focus in on the base of both of these. So both of these, the pyramid and the rectangular and the prism here, have a square base. If you notice, the base down here is the same as the base up here. They're congruent, and it's a 10 by 10 square. So capital B is 100. So wherever I see capital B in my formulas up here, I'm just going to put in 100 because the bases of both the pyramid and the prism are congruent. They're the same, so they have the same area of the base. Next, we need to find the height of the pyramid. So here, the height of the pyramid would be this dimension starting at the top vertex going to the middle of the base. Now, it creates a right triangle with the slant height of your pyramid, which they tell us is 13. It also, since it goes to the middle of the base, so if this is 13, it goes to the middle of the base, which if this whole side is 10, which we see from down here, it's 10, then half of it is 5. So this is a 5, 12, 13 right triangle. So the height of our pyramid is 12. We created a right triangle inside here. Oop, too big. Sorry about that. This right triangle in here is a 5, 12, 13 right triangle. Okay, then we need the height of our prism. Well, that's a little bit easier to see. It's the distance between those two bases is 10. So now that we have all of our dimensions, we can multiply across and come out. This area is 400, or I'm sorry, volume. This volume is 1,000, so 1,400 cubic meters is the volume of this solid. Now remember, you guys can pause and rewind, do whatever you need to do so you understand each question. If I'm going too quickly, just want to get these explanations out to you. All right, we'll keep going, just a couple more. Let's jump down to our spheres and our hemispheres. So here it wants us to calculate the surface area and the volume for each. So for a sphere, the surface area is 4 pi r squared, and for the volume of a sphere, it's 4/3 pi r cubed. And so all we really need is the radius of this sphere in order to calculate. If the diameter is 4, the radius is 2. So all we have to do is plug in a 2 for r. So 2 squared is 4. 4 times 4 is 16 pi. So this is surface area is square inches. Then we can do the same thing for volume. Plug in a radius of 2. 2 cubed is 8 times 4/3 gives us 32/3 pi. And for volume, the units are cubed. And so we get our volume and our surface area of the sphere. All right, let's put it all together now, and we'll take a look at number 19. Again, another composite figure where we have a hemisphere being stacked on top of a cone. So we're going to add those two together, kind of like an ice cream cone here. So the hemisphere, we want the volume. That's going to be 2/3 pi r cubed. The volume of a cone is 1/3 area of the base times the height. And so we can actually, with the cone, plug in our circle formulas. The area of the base is the area of a circle, so pi r squared times the height. We can just substitute that in if you'd like. And you'll see that the only variables we need in order to calculate this is the radius of the circular base for both the hemisphere and the cone. And we see if the diameter is 16, then the radius is 8. So I can go ahead and plug in 8 for the radius. As I just work across, just put in parentheses wherever I need it. And the last dimension I need is the height of the cone. So the height of the cone is from the center of the base to the vertex of the cone. They gave us that dimension is 15. This is our height of our cone. So we could just plug that in. And now we're just going to multiply across. This comes out to be, let's see, 10/24 pi. Don't forget your pi. Plus 320 pi. We'll add that together. Always want to give our answer an exact 1984 over 3 pi in exact terms if possible. We can use our calculator to get this, and we come up with our volume is 1984/3 pi cubic centimeters. So that's the volume, but remember with this problem they wanted us to calculate the surface area as well, so I'm just going to shrink that down. and actually move it to the side here so I can focus in on the surface area. So the surface area gets just a tad bit more complicated because we have to think about what parts of the outside surfaces we want to include. Really, we ask ourselves, are we including the lateral area and the base, or just the lateral area? Well, for both the hemisphere and the cone, their base is covered, right? They're stacked on top of each other. So we don't need the base of the hemisphere, we just need the lateral area. And then the same thing with the cone. We don't need the whole surface area, we just need the lateral area. So we're gonna go through and remember what those formulas are. For a hemisphere, the total surface area is 3 pi r squared, but since we're not including the base, it's just 2 pi r squared. And then the lateral area of the cone is pi r l. So we know that the radius is 8 from the work we did with the volume. So I can plug in 8 for the radius, but we need this one last dimension, which is the slant height of the cone. So the slant height of the cone is this blue dimension, which happens to be the hypotenuse in this right triangle in our cone, which is an 8, 15, you guessed it, 17, since you know your triples, 8, 15, 17 right triangle. So we know our slant height of the cone, and now we just multiply through. So we get 128 pi plus 136 pi, add those together, 264 pi square centimeters for surface area. All right, I hope that helps. I hope it makes sense. Email if you have any questions. Have a great day.